All right, so the recording has started. So if there's any questions, if there's not any questions, we'll go ahead and get started. So like I said, this is going to be a continuation of chapter 7 with the stoichiometry. Now we've already went over balancing and such. We did a bit of that. And like I said the other day, I said, Google's your friend. And so if you download balancing equations worksheets, then you're going to be well on your way to doing all right. Okay, so let's start with my favorite balanced equation. And I'm assuming everybody can see what I can write, what I'm writing. Now, if you remember with these equations, there's a 4 in the front with aluminum. You can see that right there. There's a 3 in front of the oxygen, and there's a 2 in front of the aluminum oxide. And this is a balanced equation, which means we have the same type. And, uh-oh.
Can't see Mr. Pierce.
All right, well, you should tell me quickly, so that I can, so I don't, just start yakking away. Let's see, share content. Let's try that again. So we are going to share. Well, it should have been sharing that, but okay, let's try that again. How's that?
We can see the shared Oh, there. Never mind.
There it is. Okay, thank you. Like all technology, it's just, you never know it's really working on the other side until someone says something. You know what I mean? Let me know. Let me know if it's not showing. Okay, so we got my balanced equation up here, okay? And it's balanced. Now, one of the big goals of this chapter is actually two big goals. One of the goals is to be able to balance an equation. And like I said, Google's your friend on that. Just do balanced equation worksheets. The other thing that we're going to do, that's the big point of this whole chapter, is if you can picture, what do we picture when we have like reactions going on? We have like a beaker or something, and we dump something in, and then it does something, right? Like bang. All right, that's when I picture chemistry, that's what I think about. I'm mixing a couple things together, I do something, something happens. Well, that's what the whole point of chapter 7 is about. Except this time we're going to say if we take so many grams of something with so many grams of something else, what are we going to get of what we got? That's what it comes down to, is what are we going to get? If we mix, it's not enough to just say, well, if I mix these two things together, something happens. Well, I want to know how much I got. And if you think about it, if you're like in the business of making stuff, like a chemical factory, or if you're trying to prescribe medications or whatever, you want to know how much you're either getting or how much you're given. That's important because it all costs money at the end of the day. All right, so what we're going to do is we're going to figure out how to do all this. Now, the first thing that we need to be able to do is be able to calculate what's called a molar mass, okay? This is our first skill number 1. You have to be able to do this, calculate what's called a molar mass. If you can't do this, you can't do anything. Okay, now it's not hard, and this is why I asked you to go ahead and have your periodic table out and a calculator. Okay, now I'm looking at my calculator. I don't know if y'all can see the screen off to the side, but what we're going to do is, if you look at, say, underneath the aluminum, so let's look at what the molar mass of aluminum is. If you look on your periodic table, it looks like this. You got aluminum, you got a 13 up here, and you got a 26.98. Let me make that look a little better here because I'm doing it on a graphical tablet. Come on, there it goes. And it says 26 point, oh, what does it say? 98154. If you look on your periodic table, you should see this right where it says aluminum. Okay. And I'm assuming everybody can still hear me and see me. All right. Now, what does this mean? Well, for these calculations, when we did this stuff before, this was the atomic number, right? And that was what? The number of protons. And back when we first did this in class, I said, you know what? This is not the atomic mass. This is the weighted average of all the isotopes. Now, let's see, we should still be recording. Let me make sure we're still recording. Whoops. Oh, let's see. Let's see, sharing. Yep. I'm assuming we're still recording. Hold on just a second. I just want to make sure. I'm getting paranoid about this stuff just cutting off. All right. Well, anyway. All right. So we got that. All right. Now, what are we going to do with this? Well, the first thing is that if we look at this balanced equation up here, what does it really mean when we're looking at it? Well, what it means is we're taking 4 aluminums and we're adding in 3 oxygen molecules, and we're going to get 2 aluminum oxides at the end. That's what we're going to get. Okay. But what does it really mean? It's more or less, it's a recipe. And so one way to look at this is we could say we're going to get 4 atoms of aluminum with 3 molecules of oxygen to get 2 molecules of aluminum oxide. And how would we use this in reality? Well, we would say, okay, well, I need to go get a bottle of aluminum and count out four aluminum atoms. And the same thing with oxygen. We'll get some oxygen. I got to count out 3 molecules of oxygen. Now, counting out all these molecules of oxygen would be really hard because atoms and molecules are like really small. And since they're really small, to make any amount that's useful, we're going to have to count out bazillions of atoms and bazillions of molecules. Okay, and that's not very convenient at all. So what we do is we have something called Avogadro's number. You may have heard it, and it has some mystical, magical properties for many people. And it's 6.01 or 6.02, pardon me, 6.022 times 10 to the 23rd atoms or molecules per what's something called a mole. Okay, this is a mole. Now, what this is a counted number. Actually, it's 6.022 or 6.223948, whatever, and it goes on and on and on. Tons and tons of numbers with Avogadro's number over here. Now, what does this do for us? Well, that in and of itself doesn't do anything for us, but what we can say is that if we have 1 mole of carbon 12, or C12.6, we're going to say that is exactly 12.0000, as many zeros as you want, grams carbon 12. And you may say to yourself, well, what does that do for us? Well, if you remember up here, we're actually counting the number of atoms and molecules in our equation. But what Avogadro's number does is when you define it this way, is that we can now look at this number right here that's on our periodic table, like for carbon, for instance, since I just use carbon, that's 12.011, and there's a 6 up top, right? This number here it becomes 1 mole. This is 1 mole. And it tells you how much that weighs. How much 1 mole of that aluminum weighs is 26.98154 grams. How much does 1 mole of carbon weigh? 12.011 grams. When we did the equation up top, we were trying to count out the number of atoms. Well, that's very inconvenient. But what can be more convenient than taking however much you need in terms of grams and just throwing it on a scale? How more convenient can that be? You don't have to count anything out. You just weigh it out. So that's what this does for us with the periodic table. We see that number below carbon. We see that number below aluminum. And that tells you how many grams per mole that you have. So up here, if we said we had, and let me change colors here. If we say we want 4 moles of aluminum, we would actually say 4 times 26.98154, and we would go way out 4 times that. So we would say 4 times, I'm going to say 4 times 27 because that's really what it is. And we would go out to the scale and weigh out 108 grams. And if we wanted 3 moles of oxygen gas, well, that's 32.0 grams per mole. And we would say, what's 32 times 3? That's 96 grams of that. And then if we wanted to know how many moles of aluminum oxide we'd get, well, we'd say, each one of those is 102 grams. And it's actually 204 grams of product that we'd actually get. And this is a lot. And believe it or not, I mean, chemistry looks like it's hard. Chemistry looks like it's complicated. But at the end of the day, you want to make it as easy as possible. And what is easier than just throwing something on a scale and just weighing it? If I want 4 moles of aluminum, I look on my periodic table. I see that 1 mole is 26.98154 grams. We throw it on a scale. Done. That's all we need. Okay? Now that's the big picture of what's going on here. Now what do we do practically? Let's pull all this up and let's take another look at this. What we need to know is, for instance, let me change colors here so it's not green anymore. Let's say that we were saying, what is the molar mass of aluminum from our original equation? And what we would do, we would look on the periodic table. And we would find 26 point, whatever it is, let's see, 26.98154. And then we would say 26.98145, let's see, 98154 grams per mole. Okay, that's the molar mass. And remember, and we're going to say it's moles. Well, there's my moles part. And we're going to say mass. Well, there's my mass part. Mass is how much something weighs. That's why it's called the molar mass. So if you're just looking at just the atom, say aluminum, well, what do? You just look on the periodic table. Now, as an aside here, though, generally what we do, usually you're going to want to round to 1 decimal, just because that's an awful lot of decimals to carry around. So usually we say 20, that's rounds to 27.0. So we'll say 27.0 grams per mole. So from here on out, I'm going to use just 1 decimal. I'm not going to use, all of this out here. All right. Now, what if we have the oxygen gas over here? So we want to say, what's the molar mass? It's the molar mass of O2. Now, O2 is a little different. First off, O2 is a molecule. I have 2 oxygen atoms up there. Here they are. There's 2 of them. It's not just oxygen. There's 2 of them. What you're breathing right now is O2. Okay? Now, what does that mean for us? If we look at the periodic table, we see that oxygen, element number, what is it? Element number 8, I believe. Yep, element number 8. We look on oxygen on the periodic table and we see 15, it's supposed to be 15.99, I believe. Yep, 9994. I'm actually looking at my periodic table and this is what I see. And remember, this is for 1 mole. What do we see up here? 2 mole. Okay, what do we see up there? 2 mole. And so we have to say actually, and remember, we're going to round that. We're going to round this, by the way, to 16.0. Remember, we're going out 1 decimal. Remember, we're going out 1 decimal. So we're going to say 2 times 16.0 grams per mole. And that's going to equal 32.0 grams O2 for every mole O2. Questions so far? All right, now, what about, let me pull this down here. What about the 2 aluminum oxides up here? What about those guys? Well, we do the same thing. Let's do let me change colors on my pens here. And we can say, well, what about aluminum oxide? Molar mass. Well, I look on the periodic table and aluminum is 27.0. And I look at the periodic table and I see that oxygen is 16.0 when I round it to 1 decimal. But there's 3 of them, of the oxygen. There's 3 of these guys, 2 of the aluminums. And remember, that 2 means 2 of everything prior. That 3 means 3 of whatever's prior. All right. So now we're going to say, well, it's 2 aluminums. There's the 2 right there. 2 aluminums times 27.0. And then we're going to say grams per mole. And then we're going to add in the 3 oxygens. We're going to say 3 times 16.0 grams per mole. And we add them up and we should get 102.0 grams, and that's grams O2, grams aluminum, grams aluminum oxide for every mole aluminum oxide. So how are we doing this? We're looking at it and we're just adding up what we got based on the table. That's what we're doing. We're adding up based on what we have on the table. So whatever we got is whatever we got. Now, let's try one. All right, I want y'all to try one and you tell me. Don't just look at it. Hopefully everybody's actually watching the screen, not, off, mowing their grass or something out in the snow. All right, so let's try one. Okay, let's do, what is the molar mass of, I don't know, let's go with CH2F2. All right, you got your periodic table in front of you, I hope. So what's the molar mass? What is the molar mass of CH2F2? That means there's 1 carbon, 2 hydrogens, and 2 fluorines. All right, let's take a moment to do that. And as soon as you got it, just unmute yourself and let us all know that you got it. Because I can't see you otherwise. Let's see if I can get an answer here real quick. Let's see. Yeah, I got an answer. All right, anybody got an answer? Just tell me what you got. I do have everybody still here besides Kanya. Tanya. McNair. What'd you get, McNair?
I'm still working on it.
Okay. All right, so let's look at this. We got a periodic table in front of us. And we say that there's one carbon. We got I'm going to blow this up a bit. We got CH2F2. Well, there's a 1 here, even though it's not up there. There's a 1, so I know there's at least one carbon. So we say 1 times 12.0. That's for the carbon. Where did I get that 12 from? I got it from the periodic table. And then we come down here and we say plus, well, there's 2 hydrogens, and each hydrogen is worth 1.0 apiece. And let's put that 2 back up there. And then we say there's 2 fluorines, and we look on the periodic table and we see underneath each fluorine should be 19. Let's see. Yep, 18.998. We round that to 19.0. And then we add them all up, and I get 52. What'd you get?
52 grams.
Exactly, 52.0 grams CH2F2 for every mole CH2F2. Okay, so now one thing we do need to do though is it's not just grams. We got to make sure we put on grams of that and moles of that. Kind of label them. Let's label them. All right, and it's going to be important what we do in a little bit, that we make sure it's labeled. Okay, let's do another one. All right, let me move this on up here. All right, good job if you got a 52. Good job. Let's see if you got 52, not if you got a 52. Shoot, that sounds like a test score. Ugh, not good. All right, let's see. How about we do calcium chloride? What's the molar mass? Let's go ahead and see if we can find the molar mass for calcium chloride.
Mr. Pierce,
Yes,
I got 110 grams, but I got
110.
110, 110.98 grams. Is that right?
That would be 111, wouldn't it? Rounded.
Yeah. Yes,
Okay,
sir.
well, let's see if I get the same answer here. Okay, so let's see, calcium. I look at calcium, and if I round calcium, it says 40.08, but that's 40.1. And then we
Okay.
say 2 times the chlorines. Let's see, the chlorines are 35.5 apiece. And remember, your number may differ a little bit. If you go out further than 1 decimal, you may be a little bit different from what I get, and that's going to be okay. Times 2 times 35.5, and ooh, definitely not that. Let's see, hold on. Let's see, 40.1 plus 2 times 35.5, and I get, well, look at that. I get 111.1. Now, this right here, rounding, it's okay. It's okay. It's okay. The reason why you got 110.98 is probably because you went out a few extra decimal point places, and that's okay. It's okay. 110.98, which gives you 111.0, is essentially the same as 111.1. It's the same thing. Don't worry about that. All right, because if you had gone out 2 decimal places, you would have actually said 40, what would calcium be? 40.08. And that would make a difference, a little bit of a difference, not much of a difference. Now, when you see this now, in case you're still worrying about it, going, oh my God, what do I do, Mr. Pierce? I got this, and you got that. Is that going to be like answer A and answer B? And if I don't pick answer B, is that going to be wrong? No, actually not. What'll happen is on a test, it'll look like this. Calculating that, okay? We might get 83.6, 137.9, 111.1, and 102.3. Which one would you pick if you got 111.0?
C.
Yeah, you'd pick C. Even though it's not exactly the same, you would say, you know what? It's close, right? So in other words, what I'm also saying is answer E would not be 111.0. You'd never have them that close on any test or any quiz. Okay? So, if you go out an extra decimal point, that's okay. You'll get 111, you'll get 110.98 rounds to 111.0. If you go out 1 decimal place, you'll get a 111.1. It just depends. Okay, let's do one more and then we're going to move on. Okay? I hope that makes you feel better, just in case you were wondering. Was anybody wondering about that? I bet you were. It's good to wonder about these things. Okay, let's do one more and then we're gonna try something a little bit different now, okay? So let me change my colors here again. So let's get the molar mass of, oh, what do we want to do here? How about, there we go. This is glucose. Glucose, otherwise known as blood sugar. That's what that is. Let's get the molar mass of that. And then we'll do something else. All right, you got an answer?
189.0 grams.
I got 180 myself. So that would be, I did this. I went 6 times 12.0 plus 12 times 1.0 plus 6 times 16.0, and I get 180.0. What'd you get? Did you say 180.1? Is that what you said?
It's the rounding that's throwing me off.
Okay. So what did you get?
I
What was
got
the
that
number?
answer, but it's like a 9 and a 6 after the 0 too.
That's fine. You got 190, 189.6 like that?
Yeah.
Yeah, that's fine. That's fine.
Okay.
That's fine. It's perfectly okay. It's just that most of the time when I'm doing this, 1 decimal is good enough. 1 decimal
You
is
don't have to
good.
round it after that number.
You would round that to 180.1, wouldn't you? Which is still okay. It's still okay. But I try to be consistent. If you notice, when I did all these up here, I went to 1 decimal place. I rounded the 12.011, I rounded it to 12.0. The 1.01, or I think it's actually 1.0079, I rounded to 1.0, and the oxygen, which is 15.99, I rounded to 16.0. That's just me. If some professors, they want you to go out 2 decimal places. It doesn't make any difference. It really doesn't. So don't worry about that. Don't worry about the rounding. I'm only telling you to go out 1 decimal so you don't have to carry a whole bunch of extra decimals around, which takes time. It takes time. But the answer you're going to get is going to be perfectly okay either way. Okay? Either way, this is going to be just fine compared to what I got, which is right there. Okay? Does that make you feel at least a little better? Don't worry about it. It's okay. All right, let's move on. Okay, now the second piece. All right, questions while I'm resetting up a new whiteboard here. So let me go ahead and do that. Let me pull out my, let's see if it'll let me do this with the pen here. Okay, I'm gonna start up a new whiteboard. There it goes. Okay, now, what we need to be able to do, now what can we do with this molar mass? Now, the way it's gonna look is like this. Okay, we've got molar mass, and we're gonna have a list of things that we need to look at. Molar mass is going to look like this: grams per mole. And the grams part you're going to get from the periodic table. This is just what we just did. Okay, I'm not doing anything new here. The grams we got from the periodic table, and this is the molar mass. Okay, now when are we going to use molar mass? Whenever we see grams anywhere. Okay, this is how we're going to know when we need to use the molar mass. Okay, because we should know how to calculate it, but we don't always need it. But when we do, we do. All right, so you see grams anywhere. Okay, now the first thing we're going to do is we're going to do some stuff with molar mass. Now look, it says grams over moles. Anytime you got something over something, it's a conversion factor. Just like when we did like 12 inches to a foot, or 25.5 milligrams per pill, or 2.20 pounds per kilogram. Remember using those in class? We used stuff like that, and they were all conversion factors. Well, guess what? Molar mass is a conversion factor. It ain't no different. So if we were to have, say, glucose, which is C, which we just did, C6H12O6, and we say, well, let's go with the 180. This is grams H12O6 for every mole C6H12O6. This is the same. This is the same as doing any one of these guys up here in the corner. It's the same thing. So what does this allow you to do? This allows you to go from grams to moles, or from moles to grams. Just like we had 12 inches to a foot, we can either go to feet to inches, or we can go from inches to feet. If we got milligrams per pill, we can go from pills to milligrams and milligrams to pills. It's the same thing. Okay, so how can we use this? Well, one of the things that we have to be able to do is say, for instance, let me write this, let me change colors here. We'll change colors. Here we go. I'm going to go rainbow. Why not? So I want to say, how many mole is 56.52 grams C6H12O6? Okay, here's our first question that we're going to use molar mass with. And we look at it and we say, well, gee, you know, we got moles, we got grams, but what do we have right here? I see grams, which means I need the molar mass, because that's what it says right up here at the very top, right up here. Anytime you see grams, what do you need? You need the molar mass. Okay. Now, turns out we already got the molar mass, so you just write it down. You just write it down, write it down. And we write it down. We say, okay, I got this. 1.180 grams glucose, or C6H12O6. And don't forget to label these things. You always got to label them. Okay. You always got to label these things. So we just write it down. Just write it down. Now, what we're going to do is we're going to do just like we did a couple of weeks ago. We're going to write it down as a conversion. In other words, I'm going to draw a line. Here's my line. And I'm going to draw another line. There's another line. And what lives here? The measured number. Where's our measured number? There it is. There's my measured number. And so we say, and how do I know this is my measured number? Because I had to put this on a scale. I had to actually measure this. I had to go across the room to the scale, put it on a scale, and I got a measurement. Now, anytime I saw grams, and I did, I needed the molar mass. Now, what do I need to do with this right over here, though? Well, that's going to have to be what comes next. So what do you want to do with this that I just circled? Do you want to use it like it is, or you want to flip it over?
Flip it.
Yeah, you want to flip it because we want grams to cancel. And so we do that. So we say moles C6H12O6 for every 180.0 grams C6H12O6. And looky there, look at that. The grams C6H, and I might as well circle this one too. The grams glucose cancels. You see that? The grams glucose cancels, and the grams glucose cancels. Now what do we got? What do we have left over? the mole C6H12O6. That's what's left over. And now we got something we can put in our calculator. And so we say 56.52 divided by 180.0. And I get mole C6H12O6. Now remember, I added the 0 because my calculator answer was 0.314, but this was 4SF over here. This was 4SF. This is 4 significant figures, so I needed my answer to be 4 significant figures. That's why I added in the 0. In case you were wondering. Okay. That's it. That's how you do it. Okay. So you're given the grams, and it said, well, how many moles I got? You just have to figure out what's measured. Well, that's 56.52 grams. And then you got to figure out what's the molar mass. Well, it's 180.0 grams per mole. And then you just make sure units cancel. In other words, you just got to be able to match at that point. A lot of this is going to come back to, just like nurse math, if you can match, you can make it happen. Okay, so let's try one. Okay, so how about, let's see, I'm going to put up a problem here for you. So, how many grams is 1.65 mole aluminum oxide? And I'm going to say, we've dropped this over here, erase this, and just so it would fit. How many grams is 1.65 moles aluminum oxide? And we're going to say molar mass, I'm going to give it to you, is 102 grams per mole. Okay, now go ahead and figure that out. What do you got here? I got an answer. And if you get an answer, let me know if you got an answer. Now remember, I already gave you the molar mass, so you don't have to calculate that. So what do you get?
I got 0.016.
Gotcha. Well, let me see. What did I get here? So I said, you know what? I see grams. Let me change colors here. So I see grams. So I know I need the molar mass. But I have it right here. Okay, so I just write it down. All right, now the next step is figure out what's my measured number. What is my measured number? It's the 1.65 moles. So what I'm going to do is I'm going to draw a line, and we'll draw a line. And I'm going to say 1.65 mole aluminum oxide. All right, so how do you want to use that? You want to use it like it is, or you want to flip it over?
Flip it.
Why would you want to flip it? If you flip it, well, I'll do what you want me to do. Okay, what's the problem here?
Okay, don't flip it.
Yeah, you see what I'm saying? The moles won't cancel. So, nope, you do not want to flip it because why? Because we want units to cancel, okay? And so if we don't flip it, then what happens? Then what happens? Moles aluminum oxide cancels, don't they? Now what do you get? Should get 168. Do you see that? Now what you have to do here is whatever you do, don't try to guess whether you divide or multiply. In other words, don't look at it and say, oh yeah, I remember anytime I have this going on, I have to divide. Or anytime I have this going on, I have to multiply. Don't do that. What you do is you let the units do the setting up for you. Let the units set it up. Okay, because I think that's what happened here when you said point something. Is you probably say, well, I just divide. Well, no, actually, no. You whether you divide or multiply depends on how the units are set up. Okay, do you see what I'm saying? Yeah, hopefully you do. Okay. All right, let's do another one. Why not? Let's do one more. We got time for one more, and then we'll call it quits for the day. Okay. And then we'll pick up on this on Tuesday. So let's do one more. All right. So here we go. So, all right, let me change my pen here, make sure my pen's going. All right. How many moles is 4.18 grams CF4? Okay, let's get an answer out of that, and then we'll be done for the day. I've got an answer.
May I ask, did you get 88 grams of CF4 for a mole of CF4?
Let's see. Yep, sure did. Sure did. I got 88 grams per mole for CF4, carbon tetrafluoride. So, well, the first step, is you see grams, right? So I'm going to need the molar mass. That's 12.0 plus 4 times 19.0 for the fluorines. And that gives me 88.0 grams CF4 for every mole CF4. All right. So what did everybody else, what did you get for the final answer though? Well, if we look at this, we've got the molar mass. What's our measured number? That's my measured, because I had to throw it on a scale. That's what makes a measured number, is you throw it on a scale. And we got 4.18 grams CF4. Now, how do you want to use this over here? You want to use it like it is or flip it over?
Flip it.
Yeah, you want to flip it because you want grams on the bottom, so the grams will cancel. There it is, and I put that in my calculator. Hopefully I didn't mess that part up. And I got 0.0475 mole CF4. That's what I got. What do you think? Did you get that?
Yeah.
Well, all right. See, it isn't that bad. It isn't bad. So what we're going to do Tuesday is we're going to do what's called mole to mole, where we're going to have a balanced equation, and we're going to go from one kind of moles to another kind of moles, and we're going to put it all together into one big equation. That's what we're going to do next Tuesday, okay? Now for lab today, after we're done here, at some point I'm going to go ahead and post it, the online version. So sometime by next week, we can go ahead and have that done, okay? All right, everyone? All right, any questions before we call it a day?
Did you say the lab would be due next week? So
Yeah,
not
lab.
not today?
Yeah, we'll just make it due next week if that's okay for everyone.
Sure is.
Yeah, I mean that's all right. You know, as long as we get it done before the next lab, I'm happy. Yeah, so thanks everyone for coming out. I really appreciate it. It makes me feel like maybe we're doing something important here. So, try to stay safe. If there's no questions, we'll go ahead and stop sharing here and move on from that. Okay.
Thank you.
All right. No problem. Y'all have a great day. Okay. Bye.
You too.
Have a
You
great
too.
day.